We are on to our next topic for this chapter, and this time we'll be discussing about minerals. Again, the big idea is that Earth's rocks and minerals are economically valuable resources made possible through extraction and mining and processing. And these are the different learning competencies that hopefully you guys will be able to achieve by the end of this chapter. All right, so the common question is, what is a mineral? So, is a mineral the same as a rock? Okay, so a mineral, take note, is different from a rock. A mineral is naturally occurring, it is generally inorganic solid, and it must have an orderly chemical composition as well as a well-defined chemical composition. So we have to take note that these characteristics must be sufficed by an object for that object to be considered as a mineral. Okay, so take note as well that a rock is actually an aggregate of one or more minerals. For example, coal is a sedimentary rock and it is composed of carbon. Okay, so let's now move on to the physical properties of minerals. The name of the mineral may be based on the name of its discoverer, location, where the mineral was found, or the mineral's chemical composition or properties. The common suffix of mineral is "ite" or "ite", and it means belonging to. Right. So here are the different properties of a mineral. So first we have crystal structure. We also have hardness, color and streak, crystal habit, transparency and luster, cleavage, and specific gravity. Okay, so let's discuss them one by one. First of all, crystal structure. So minerals may be classified based on their crystal structure. Crystal structure is a description of the orderly geometric spatial arrangement of atoms in the internal structure of a mineral. There are 6 crystal structures as shown in the following table. So first we have isometric. So all of the sides are equal. An example for that would be halite and galena. We also have tetragonal. Example for that is or are calcite, zircon, and chalcopyrite or chalcopyrite. We also have orthorhombic. Example for that will be sulfur and staurolite. We also have hexagonal. Example for that would be quartz and calcite. We also have monoclinic. Example for that would be mica or mica and gypsum. And then finally, we have triclinic. Example for that would be feldspar and rhodonite. Okay, next we have hardness. So, hardness refers to the resistance of a mineral to being scratched. And this property is dependent on the chemical composition and crystalline structure of a mineral. The most common scale of measurement is Mohs scale, created in 1812 by German mineralogist Friedrich Mohs. And this scale or measuring hardness using the Mohs scale is described through the use of 10 mineral indicators as shown in the table. A mineral with a lighter or with a higher index can scratch those below it. Since the minerals of the Mohs scale are not always available, there is another way of identifying hardness. It is through the field hardness scale. This is done by using common tools or objects to rub or scratch against a mineral. So as you can see here in the picture, if we're going to follow the Mohs scale of hardness, it is said that diamond is the hardest mineral, which means that only diamond can scratch all through the other minerals like corundum, topaz, quartz, and the rest. And the softest mineral, according to the Mohs scale of hardness, is talc. So that's the softest. So as you can see here on the last column of the table, there are common objects which we can use as reference to see or to know how hard these minerals are. Okay, next we have, okay, so by the way, we have to take note as well that The Mohs scale of mineral hardness is linear and is considered a relative scale. For example, um, the scale suggests that corundum, which is 9 according to the Mohs scale of hardness, is 1/2 as soft as diamond, which is 10. But in reality, it is actually 4 times as soft. So to account for the nonlinear discrepancy, scientists develop a proportional measurement known as absolute mineral hardness through the use of an instrument which we call as sclerometer. So the instrument accounts, or this instrument accounts for the large difference in hardness as one approaches the higher end of the Mohs scale. Okay, next we have color and streak. So how is color different from streak? So take note, color is the color that we see or that is perceived by our eyes, and streak on the other hand is the color of the mineral in its powdered form. Okay, so take note that minerals come in different colors, especially mineral gems. The mineral gems that are used to make jewelry are rare. Examples of mineral gems commonly referred to as gemstones include diamond, emerald, sapphire, ruby, opal, aquamarine, turquoise. It also includes jade, topaz, garnet, amethyst, sandstone, and among others. Um, the streak of a mineral, like what I have said, refers to the color of the mineral in its powdered form. You can find out the streak of a mineral using a test plate such as the backside of a porcelain tile. The streak may or may not be the same as the body of the mineral or body color of the mineral. So as you can see here in the table, it shows you the images or the direct images of the minerals are actually the colors that we can see if we look into the mineral. But the one that is written like light blue, white, colorless, that is the streak. So for example, let's take azurite. So if we are going to look into it, it somehow looks like whitish or grayish. But if you check the true color of this mineral using the streak test, you'll see that it's not actually grayish white, it's actually light blue. So take note that streak gives you the correct or the original color of the mineral, because there are a lot of other factors that may influence the general or the apparent color of the mineral. That's why you need to test it through the streak test for you to see what is the real color of that mineral. So another example, here's number 8, we have magnetite. So if we are going to look into it, it appears gray. But if you do a strict test into it, you'll notice that the color or the real color of that mineral is actually brown. Next, we have crystal habit. Okay, so crystal habit refers to the overall shape of crystal. And the common shapes include needle-like or acicular. As you can see in the picture, it looks like a lot of needles. We also have dendritic or plant-like. So there are like leaves that are being imprinted on the surface of the mineral. We also have reniform or kidney-shaped. We also have bladed. Next, we have elongated. We also have prismatic or in one direction. And we also have tabular. So it appears like tablets. Next property, we have transparency and luster. So a mineral is considered transparent if it allows light to pass through and you can see any object through it. It is opaque if light cannot pass through and you cannot see any object through it. And then finally, it is considered to be translucent if it allows some light to pass through and object cannot be clearly seen through. So examples for that would be for transparent, muscovite. For opaque, we have hematite. And then finally, for translucent, we have jadeite. Okay, next, luster indicates how light is reflected off a surface of a mineral. Some of the qualitative terms that describe this property include metallic, if it looks like a polished metal, like example would be galena and pyrite. It can also be glassy or vitreous if it has a luster of a glass or it appears glassy. An example for that would be silicate. It can also be described as pearly if it has thin transparent sheets reminiscent of pearls. So example for that would be talc. It can also be dull if it has little to no luster like hematite. It can also be greasy if it resembles fat or grease. So example for that would be halite. And then finally, it can be silky if it shows parallel arrangement of fine fibers. So example for that would be gypsum. Next, we have cleavage. So cleavage refers to a mineral's resistance to being broken. It describes how a mineral breaks along planes of weakness. The quality of cleavage can be described in how clearly or easily the mineral breaks. So it can be perfect, it can be good, distinct, poor, or indistinct. Cleavage can also be described by the number and direction of cleavage patterns or planes. Depending on the quality, minerals may break into smooth, flat surfaces or irregular concentric ripples. So this image here shows you the different types of or sample of cleavage direction. So as you can see here, it can cleave in one direction, like in muscovite. It can cleave in two directions, like feldspar. It can cleave in three directions, like halite. It can also cleave into two different directions, like calcite. And then we have specific gravity. So specific gravity is a measurement that determines the density of a mineral. Two minerals may have the same size, but their weight would be different. Specific gravity is determined by comparing the weight of a mineral relative to the weight of an equal volume of water using this formula. So as you can see here in this picture, these are different representative minerals and their corresponding specific gravity.